Okay, this is the second of these simulations. This is BPM. We're going to look again at the motion. We're looking for what kind of motion we might have. You would run the motion. You can see the device object moving to the right. Okay, and at this point you would want to try to figure out if you can tell what kind of motion it is. Again, your choices are constant position at rest, constant velocity, either positive or negative, or constant acceleration, again, either positive or negative. It's going to be one of those. I also want to describe the tracking shape, the pictures there left behind, and the distances between them, because that'll tell you. Be another confirmation of what kind of motion you have. Then we're going to go ahead and step forward and collect data, again from the green displacement, how far we are from where we started. The red velocity, these are the same colors your book uses for those vectors, and for various points of time. So at 0 time we have 0 displacement and 0 velocity. Then we're going to step on forward to 0.5 seconds, and that is 0.25 meters and 1 meter per second. Then we'll step forward until we get to 1 second, and that's 1 meter and 2 meters per second. Go ahead to 1.5, and that's 2.25 meters and 3 meters per second. And we'll go to 2 seconds, and we're 4 meters and 4 meters per second, a nice match. Then we go forward to 2.5, and we get 6.25 meters and 5 meters per second. And the next one will get 9 meters and 6 meters per second. Now we're at 3.5, and we're at 12.25 meters and 7 meters per second. And then at 4 seconds, we're at 16 meters and 8 meters per second. So as you fill in the table for that, hopefully you can see the pattern of what's happening to our displacement and our velocity. And it'll give you some idea of the kind of motion that you have. You also want to use that data to then calculate the acceleration value. Again, that should be constant, so you should get the same value each time if you're doing it correctly. It may be 0, it may be positive, it may be negative based on the type of motion that you have, but it should be constant. Again, looking at the graphs, this time the displacement graph, the position that we're moving at, actually curves. It is a parabola, part of a parabolic or quadratic shape. Again, the motion map would show up on this side, so as the time is increasing, we're covering more distance, so we get a curve to the graph. Then the velocity graph, the red graph, shows how fast you're going, not your position. So if you look at the pictures, it seems we're getting faster, so we should see some kind of increase, and sure enough, we get a line that increases up and to the right. Now the slope of the green graph, displacement versus time, will tell us how fast we're going, and then the slope of the velocity graph would be the change of velocity divided by the change in time. That's the rate of change of velocity. That is the acceleration of the object. Now notice that slope of the velocity graph is constant, so the value of the acceleration is constant. Okay, so calculate those accelerations. That's another part you have to finish there, and then you'll be ready to move on to part C.